Hello students, we are back in the same lessons about the subject of the formula. As we did in the previous videos, we introduced what the subject of the formula is all about, we defined what a formula is, and you are now be able to know what a subject is in a particular formula. So first of all, request you before we proceed our discussion here, you revise what we discussed in the previous video so that you have to understand from what we started up with. Right, so today we are looking at the next section in the change of the subject of the formula. As previously, if you are to remember, we had to change the subject of the formula involving equations which are retro and also the equations which have got what? Powers. So today we'll first look at the issue that about the change of the subject of the formula of the equations which have got roots. Right, then after, we're going also to look at the change of the subject of the formula of the equations, which involves the logarithmic equations. Right, so please get tuned and we'll be together there. Have a pen, script somewhere where necessary. We can solve some of the exercises that I'll give you here at the very end. Right, so now let's get into business. Subject of the formula involving loads. Here I have got two examples of which, then after we shift to the next section. Right, so can you take note of the following examples? We're asked to make the rate and the subject in, okay, because of the space. Allow me just write the questions as such. The question reads like, make the letters in the bracket the subject of the formula. The first equation is given as B equal to square root of that is 4 pi r cube over that is 3 h. We're asked to make that's the r, the subject. The second one is equation which is defined as V as the subject in this case equal to root over GD open bracket 1 that's a plus 3h over D. Right, so here we're asked to make D the subject. Right, so these are just two examples of the equations which have got roots. So we need just have to discuss on how best we can handle each about the roots as such. Right, but all in all, the process remains as we started with the previous examples. So can you go back to the videos in case you have forgotten? Right, so here, let's begin with the first one. How do we make R the subject of the formula? Right, so based on what we discussed that time, we can apply those concepts into this 4 pi r cube over 3h. Right, so here what we have is B. As you can see, B is the subject. Now we'd like to change the subject to R. But now if you can look at R, you find that R is found inside a root. And again, that same R is part and parcel of the equation. But still more, what we want is R being the subject, simply meaning that R should be defined in terms of the other what? Variables, as per the definition that we had that time of the meaning of the subject. Right, so now, what is the first thing that we do in attempt to make R the subject? So obviously here, we need first of all have to get rid of the root. So here, how do we get rid of the root? That's the main emphasis here. Right, we should understand that one out. Like say for example, if we can have root of a 2. If somebody might ask me to get rid of this root here, of this number 2, you find that the only way how I can get rid of this one is by squaring that expression. So in this case, I'll talk of root of a 2 squared. So if I square that, definitely I'll get what? Root of a 4. Which at the end, I'll have what? A 2 in this case, because we talk of the square root of a 4 is just a 2. So it means root of a 2. If I'm getting rid of the root here, what it means is just a matter of squaring that one. So if there again you have got a cube root of a 2, if I would like to get rid of this cube root, what I should do here, I need to have to multiply root of a 2 3 times as much. And at the end, I'll have what? That is 8 here, here to be it will be what? The stroke of the cube root of 8, which gives us a 2 in that case. Right, so that's the idea that we're going to channel out here in order to make a variable the subject for every time we have got a root which are being involved in. Right, so here we have to remove this one out. We have got a cube root of this one, not with a power again, would have got something else. But here we have a square, we're multiplying this one 3 times. It means this, you don't have to write another power 3 here. It means different thing all along. So with these same ideas, what it means here, we need to square the left-hand side in order to remove this root. So now, the rules of the equation say that if you are tampering one equation, the same measure has also to be done to the other side of the equation. So here, I'll take the square of this one here, like this, to remove the root. So here, I need also to square that. As such, we have a situation which is b squared equal to, if I square this, by the simple example which I had here of squaring root over 2, you should be in the position to obtain 4 pi r cube over 3h. That here, this side, it would be b squared as such. Right, so you square, if it was a 3, if it was a cube root here, it means here we have to multiply b 3 times, and this side should also be multiplied 3 times, and it goes like that. So let us see, maintain a 2 here, and here we're going also to maintain a 2. We are squaring in order to move a root. Now from there, what do we have? By previous videos which we discussed that time, you'll be in the position that to remember from what I said, every time you have got an equation which have got fractions, the first thing is you have to get rid of that fraction. Right, so like here, our fraction is 4 pi r cube over 3h. How to get rid of that fraction? You just need to multiply both sides by the denominator of the existing fraction. So here, it means I'll have to multiply this side by 3h, this side again by 3h. So what do I have? Here, it would be 3h b squared, and here it would be 4 pi r cube, because here you'd be like 3h, this will cancel with that, and then here multiply by 3h to get this. So when this one cancels with this one, we're just remaining with this one here, it'd be just like this, getting to that one is 1, then this one, you get this, and here you multiply the same 3h to the left-hand side in order to balance up the equation. So here we're getting this. Right, so that's what we're doing to get rid of the fraction, multiply both sides by the denominator. Right, so now here we are happy because we have got an equation which has got no fractions at all. Now, what is it that we're going to do next? Obviously, the moment we have got rid of the fraction, we need now there to look at the variable itself, which is r. What are the other variables which are attached to it? You find that here r is attached with 4 pi. So we have to get rid of this 4 pi and have the r alone. Right, at the very end, we got rid of the 3 that is on top there. Right, so to get rid of the 4 pi, what we're going to do there, we don't have to multiply, but we need to do what? Divide by 4 pi itself. So as I said, when you divide on one side, or the same measure you tamp on one side of the equation, that has also to be done on the other side. So here I divide by 4 pi in attempt to get rid of this 4 pi here. So what I've done there, it means this has affected up or violated the rules of the equation. So to maintain the standards, I need also divide by 4 pi on that side. So here it means like 4 cancels with 4, pi cancels with pi. Right, and that as such, on that side, we're going to remain with the r cube, but this other left-hand side, we have got 3, that's the h b squared over 4 pi. And this other side, we have got r what? R cube. Right. Finally, to make r the subject, we need to get rid of these 3 here. Right. So now, that time it was a root. To get rid of the root, we are there, like say if you have a square root, we just multiply, we just square up the terms on both sides. But now here we have got a power. It means the opposite has to be true. Right. Which is the opposite? We need just have to take the cube root on both sides. If it was here, r squared, we would have taken the square root on both sides. So to get rid of this r here, obviously, you tell me how to take the cube root of r cube. That's what we should do. Right. And indeed, the cube root of r cube is what? R. Right. So that's what we're going to do here. If it was a square root, we would have taken the what? The square root. If here there was a 2, would have taken the square root, but here we usually don't like a 2. We just leave it like that. We take the square root of r squared. So those are the tactics that we need to be able to know each time we are dealing with the roots as such. Right. So here it is 3. The power here is the 3. So to get rid of that 3, I have to take take this cube root of r cube. So if I take the cube root on the right hand side, the same measure should also be applied on the left hand side. So cube root of this one is equal to r, but the cube root of this one is not all that direct. So here we'll leave this expression in the cube root as such, which is the cube root of h b squared over 4 pi. So in this case, it means r has been made as the subject. Right. So what is more important here? Just focus much on the part on how we are handling issues about the roots. But the other steps or say procedures are just like the ones we have just been using in making the subject of the previous examples in the last videos. Right. So that's what we do. Just a simple topic as such. Changing the subject. You have the subject as a B. Now it comes into be R like that. Can we go to example B? Right. For example B, it is just also obvious that we're going to pass through the same, but a little bit of application has to be done. The steps themselves be able to tell you at this stage, do this, do that. Right. Now here we are. B. What do we have here? We have V as the subject, which is equal to square root of what? That is GD multiplied by 1 plus, that's a 3H over D. Look at this one now. Right. So you don't have to be afraid with the equation as such. What you should be there, just try to remember the tactics. You look at what is found in the equation. Do you have roots? Do you have good fractions? You do just have to know how to get rid of those and you proceed with it. Right. So here, there's a root there on the left hand side. But what we want is a D. One D is outside the bracket. Another D is inside the bracket. But both D's are part of the expression which is found inside the root. So what we do there, the first step to do is to remove something that is first. That is now, in this case, is the root that is lapping up all terms inside it. So to get rid of the root, previous example, which I've just said, in this case, you just have to square both sides. So if I square this side here, obviously, that square root will go. But if I've done that, it means the same measure should also be applied on the left-hand side. So if I square V, I'll get V squared. If I square this left-hand side, I'll have GD1 plus C 3H over D. Right, squaring both sides, we get that. Then now what next? What we want is the D. But now, if you look here, we'd find that D is observed in two situations. One D is the part and parcel of the GD, the term that is the outside the bracket, and another D is part and parcel of the fraction. So to go ahead of this one, you can think of multiplying this one. You can expand, removing the brackets here, or else you can just first of all start by dealing with the GD that is outside the bracket here. Right, so let us first of all omit the GD, and this can be omitted only by dividing by that term outside the bracket itself. So I have to divide here by GD, here also divide by GD, because that is the only way how we can get rid of that. So here what do you have? GD gets into GD once, but you don't have to write that one, just say that one is cancelling that one, we know that it was only the one. Then we have V squared over GD. This gives us what on the left hand side? We have got a 1 plus 3H over D. And then no need for you to write the bracket for that one. Right, because the term that made us to come up with the brackets has already been eliminated. So it means the right hand side we have got 1 plus 3H over D. Left hand side now we have got V squared over GD. Now what next? The fractions. So remember what I said about the fractions, how to get rid of the fractions. So you can be able to see that what we're doing here in the subject of the formula, there are some important areas that we need always to take note of, and these are just always there. So just like how do we deal with the roots, how do we deal with the fractions, arrangement of the terms, things like that. So master the concepts as such. Right, so here, what do we do? Let's get rid of the fraction and have a good linear equation which have got no fractions. So obviously, from what I said, you need to take note of the denominators. Here now there are two. If you have got two denominators, what you do there, just find the common denominator. In short, if you have got more than one or have got many denominators in the equation, you need just have to find the common denominator, then multiply by with every term within that equation. So here denominator is GD, there is a D. You'd be able to rewrite the common denominator for GD and D is GD. Right, so I'll have that denominator multiplied by every term. So V squared over GD will multiplied by what? GD. Then this one is equal to 1 multiplied by GD. Then plus 3H over D multiplied by GD. Who got that? Right. So here GD cancels GD, get a 1 there. And here we're meeting with V squared. And this time this one give us GD. And here D cancels with another D. So at the end we have got plus 3HG. That's what we have. Now a term that has got D as of our interest as the subject is this one here. So we need to get rid of this other term, which is 3HG. So to get rid of this one, you can just transfer this one to the left-hand side. At the end, you have got your V squared. This comes here, it'll be negative 3HG. And on the right-hand side, now we have got G, D, such. So our target is a D to be the subject. So what do we do there? We have to get rid of the G. To get rid of the G, at this instance, you can be able to see that now that G is more like the coefficient of a D. So get rid of that one. And the operation that we can apply here is the division. Nothing else. That's the one that can help us to remove the one, the G. So here I'll divide by G. Here again I'll also divide by G as such. So at the end, what do I have? G cancels with G, and there I'll remain up with that expression, which is the stabbed as V squared minus 3HG over G. This one gives us a D. So D has been made as what? As a subject. Right, so that's it about the root. Can we now take our further step on something else? This one, you can be able to sit down and revise. Very easy to master the concepts of which. Right, now, what if now we have got other equations of different kinds where such operations may not be viable first? Right, there are other areas that we touch. We may decide sometimes to involve the issues about the logarithmic laws and exponential equations as such in order to make a particular variable as a subject. So in the next example, let us look at such type of equations where they may need us to apply the concepts about the what? Logarithmic equation as such. Right, so let us take the next step here. Change of subjects involving equations that are related with what? Logarithmic equations. Right, so change of subjects. I'll talk of the equations. I'll just like to read in brief. Equations involving logarithmic equations. Right. Of course, ideally, this topic have not been covered about the logarithmic equation. It is the next that we're going to discuss, but still more. For those who have good knowledge, you know, have got some who are repeaters here, you can be able to understand whatever will be involved in here, because it might not be easy for you to make a variable as a subject direct as we have been doing in the previous examples. So let us try to understand, but those who have got no idea about logarithmic equation, please don't worry. It is the next topic that we're going to discuss. So be able to get some skill from there and then come back and revise the videos and you'll be able to be in the systems. But those who are repeaters, I have hope that whatever we do here will make sense. Right, so which are these examples? Right, again, because of space, I'll just read the question and then write the equations as such on the board. Right, here we are asked to make the letters in the bracket, the subject. First one, we have got P, X, P to the power X squared, right, is equal to T. We are asked to make that's the X, the subject. And the second one is an equation whose subject is A, where A equal to P, open brackets, this is the 1 plus R over 100 to the power N. So here they want us to make N as the subject. Right, so this one we have here. I thought we should also have something about this one, because what comes in exam does not beat a drum. Any equation can be given. So we're talking about the literal equations, equations involving powers, equations involving roots. Now we are looking at something else now. Equations involving logarithmic equations. So all these skills need your attention. Please master them. Right. And you can also maybe solve some questions, the past papers, things like that. Check what is there. The past papers, manual, mock, boxy. Try to apply the concepts we are doing here. So I also have to wrap this part here because of space. Right? First one is P X squared is equal to T. Right. So by the principles of the logarithmic equations and the rules attached, if you have got this type of equation, P to the power X squared is equal to T, you may be able to appreciate that this is an exponential equation. So if we are there to make X the subject to the formula, the first step that we would do here, and really it is not very easy to make X the subject in this case. As you can see, if we were to apply the methods or the skills that we have just learned in the previous example, it's quite a different example, such different equation as such. So that's why here other applied knowledge are coming in. Right. So what you're supposed to do here, you first have to take the logarithm on both sides. See, if I take the logarithm on both sides, don't take on one. As I said, the same measure you do on one side have to be applied on the other. So like here, for example, if I take the logarithm, I'll think of taking the logarithm on this side. It means I will have logarithm of P X squared is equal to, here should also be logarithm of what? AT. So you can just write a log. So in short, what I'm trying to say here is just like if you have got such type of equations, which you realize that is an exponential equation, I'd like to make an exponent. This one is an exponent already. As a subject, you can go by first of all taking the logarithms on both sides. You take the logarithm of this term, you take the logarithm of that term. Right. And once you have done that, then you bring in the principles or the rules of the logarithms. So like here, when I take the logarithm of both terms, this one and that one, I have got this situation. Now, by the rules of logarithms, if I'm going to handle this one, this is as good as having this term here to come to this one, towards that side, or this one to be the coefficient of the log of P. So by rules of logarithms, what we have here from this side here, we'll have X squared log of what? Log of P is equal to logarithm of AT. I have hope that those people who have done logarithms, they're able to understand this rule here. But those who have not done it, don't worry. The next topic you'll be able to understand what we're doing here. So log of P to the power X squared is equal to log of T is as good as writing X squared, this term here, log P equal to log of T. Right. Now, what is it that we want now? Once we have arrived at this stage here, now you can apply other concepts. Like for the previous example, we are already there. All the skills that are there, we have discussed in the previous example. Now they can be applied. So like here, what we want is x. So it means we have to get rid of what? Log of AP. To get rid of that log of AP, what do you do? Just divide. So x squared here, log of AP is equal to log of AT. I just have to divide logarithm of AP here. Then I also get divide by logarithm of what? Logarithm of AP. Right. So what do I have here? This cancels to that one. So here I name it what? X squared is equal to log of AT over log of AP. That's what we have. So what is more important here? It's just a matter of this stage here. The rest of the stage here are the things which I've already discussed. And you don't have to be having those hectic issues in your brain. No. Usually maths is simple. You just have to have an opening key, and after, what do? You just apply the normal thing that you already know. So look at what we're doing here. It looks as if it is difficult, but now we find that what we have done here just very simple and straightforward. So what we want is x. And you tell me, as far as here, this x has got a power 2, then obviously to get rid of the power 2, what do? You have to take the square root on that side. So if you take the square root on this side, you have to also do the same on the other side there. Right. So what I want there is x. So what I'll do there, to have x as a subject, I need to take the square root of x aside. So take the square root of x, that means x. I'll do the other side, it means that one will be now logarithm of what? T over log of AP. And this ends the story like that. So which means the first part of the equation, this is what we have here. Right. So for B, I would feel like you students, you can try that one out. I don't think if you face some problems with this one, just a simple application. What if now we make the P, sorry, the N as the subject? Right. So what I want you to do here is just a matter of trying to ask you to make it, that's the N as the subject, right? You do practice that one, but I'll give you the solution that you have to target upon. I'll need you to almost just like show that maybe in this equation here, N is this. N is equal to, yeah, but now I should not give you the solution to this one. Try it as an example. Right. So take this one as an exercise. If I'll solve this one again for you and give you the solution, some of you just leave it like that. So all in all, you do the same as we have done. Maybe let me just begin with just a first step here to have, like, say, A is equal to P 1 plus R over 100 the power N. Right? Obviously, what we do here, you tell me that the first thing we do, we have to divide by what? AP. So if I divide this one now by P, I also divide this one by P. Okay? So here I've got A over P, and this side we have got 1 plus R over 100 to the power N. I think let's just finish it together then, because I've just studied it. Some of us can have some problems maybe here and there to say, what about the inside there, there's that. No, you don't have to be despaired by that. So A over P is equal to 1 plus R over 100 raised to the power N. So what is there? What you need to do is just a matter of coming here and get the nth root of this on both sides. If it were power 2 here, you would have taken the square root on both sides. But now instead of a 2, we have got n. It means this one has to have A over P, and then what you have here, you talk of the, that's the talk of the nth root like this one, and I will write it like that. And this gives you 1 plus R over 100. If it was a 2 there, you'd have taken the square root. But now this n, you take off the nth root of that one, this case. So what we want there is what? Is R. So what do we have now here? You need to, again, now here, what you need to do is just a matter of considering the situation here you have at hand. You'll have, like, when somebody writes like this, that is as good as having a to the power n, root of n, nth root of n over p, root, okay, that's the nth root of p. That gives you 1 plus R over 100. Right. Then from there, you have got a fraction. This is the fraction, that is the fraction, and then find the common denominator. You can proceed with that. Right. But if you would like to use the logarithmic equation, that's another way around. So this is when you don't want to use the logarithmic equation, you can go by this one here. That's the method. Right. But if it is about logarithmic equation, you can take the you can transfer this one to this side here. There are two approaches here. One, if you want to use it just like the method I've done here, by just dividing both sides, you get this one. Like, it's a good question to be discussed. You can go by this channel here without logarithms. I've studied here. You divide by p as I've done this case, then you take the nth root I've done here, you go down like that. So here you can proceed with that one out, because what you do, just have to multiply every term here by the denominator. Without wasting time, you may have the denominator, that is 100. That's the talk of the nth root of p. You multiply by this one, multiply by that one, multiply by that one, it goes. Right? Oh, with what we are doing here, for this part, it means you'll have this. A is equal to p, open brackets, 1 plus r over 100 the power n. One can decide to divide still more by what? By p, and have a over p equal to 1 plus r over talk of what? That's a 100, like this. This is power n, same like this stage here. But now, instead of going for the nth root on both sides, what we could do sometimes, you can just get the logarithm on both sides. And here it means you have got log of a over p. Here you have got log of 1 plus r over 100. This is the power n. Right. So what do you have? This will come to this side here. You have got log of a over p equal to n. Log of log of, that's a 1 plus r over 100. That's what you can have in this case. So there's just like two operations that I wanted you to take note. You can go by this one here. It's a methodology using the logarithmic processes, or else you can go by this other process here by taking the nth root on both sides. So both solutions will just be the same in this case. So look at this one, critical well. When you arrive at this stage here, I should just guide you that multiply both, okay, all terms by the what? Common denominator of this fraction and that fraction. Or we go by what? Logarithmic process. So you take the logarithm on both sides, log of a over p, log of 1 plus r over n raised to the power n. So the n comes here. So at the end, you just have to divide both sides by this one. You divide by this one on this side. This one will go, you remain with n, and again there you're going to divide by the same. Then n has been found. So what you have found there and what you get here mathematically, it means the same. So I'll need you at least to play around with the two processes on the paper and see how the two answers compare. Right. Thank you very much for being together on this part here of the talk of the subject of the formula that deals up with the talk of the roots and the logarithmic equation. So my assignment, please, can you proceed with this one? Proceed with that one. I've already given you the guides. Thank you very much for being together. And let us be together again in the last lesson, where we need just have to have the applied problem in the subject of the formula, and that wind up the topic as such. Thank you.